Good evening, everyone. I'm a sitter. I'm not a stander and a walker. I'm a sitter, so I hope that's okay with everyone. Tēnā koutou katoa, noa Texas aho, kei te noho aho I o tautahi e nai ane. He ahoe aho ko Maggie-Lee Huckabee, toko ingoa, na mihi nui ke a koto. And I hope I haven't offended anyone with my pronunciation. Forgive me, I'm learning. So, thank you very much for joining us this evening. What I said in that very brief and poorly articulated introduction is that I'm originally from Texas, and actually if I have a glass of wine or two, I really sound like I'm from Texas, but most of the time I put that away. I've been in New Zealand now for about 22 years, and funny, the American accent just doesn't seem to go away as it goes. But I very well and truly have made Christchurch my home, and I'll be here until somebody puts me in the ground, and then I'll still be here, I guess, as it goes. So I don't have any plans on going anywhere. I'm a distinguished professor at the University of Canterbury in the School of Psychology, Speech and Hearing. Distinguished only because I'm very old at this point. I've been here for a good long while, so that buys you something, I suppose. My name is Maggie-Lee Huckabee. So I have a couple of announcements that the university has asked me to make. Certainly, Harima, I am welcome to the university for this UC Connect lecture this evening. The lectures are free, and they'd like to thank you for coming to attend to this talk. If you've not already done so, you can sign up out front to be alerted to upcoming lectures if you're interested in that. I really personally thank you for joining me. I think I'm the only one up here. That I really love the work that I do, and I look forward to spending a little bit of your evening telling you about why it's so interesting, and I think why it's so hopeful, I suppose. So that's my goal for this evening, is to just share a little bit of the pie of what I do as it goes. General housekeeping, the toilets are just outside on the ground floor, this side, either way you want to go. If you hear a fire alarm, that's a bad thing. So follow the UC staff directions. They're the folks in the black jerseys with UC. There's one here, one out front, so just follow their instructions. They'll take you to evacuation points. Try to stay together as a group if you can, because we know how many of you there are, so if some of you wind up missing, that could be a point of concern, so stay together. In the unlikely event of an earthquake, stay where you are, take shelter, don't evacuate unless you're instructed to do so. Should evacuation be necessary, the assembly point, once you exit the theater, is on the walkway outside the geography building, just this direction. While you're on the UC campus, you can use the help tower points to contact the UC security team, and turn your cell phones off, please, if you have not done so already. And I think that I've just gotten through all of the instructions as it goes. So I'm planning on talking for about 40 to 45 minutes. After that length of time, I really welcome your questions. I think these sorts of lectures, the most interesting part of the lecture is what you talk about after the lecture. It's not so much what goes on during the lecture. So I hope that you will all be comfortable in opening up, since we're quite a small group, I suppose. So, to get started on this, in the last 90 seconds or so, you have all executed one of the most complicated, complex tasks that occurs in the human body. That you have recruited 32 paired muscles, so that's 64, and 65 if you want to include the diaphragm, that those muscles are orchestrated by 7 cranial nerves and multiple parts of the brain to perform this task that takes about 800 milliseconds. And you probably didn't even recognize when you did it. It all just happens automatically. And so, of course, what you would have done then is you would have performed a swallow, which we all do many, many times. If you're reading a book at night in bed and you're really not thinking about swallowing, because generally who thinks about swallowing unless you're me, then you would probably swallow about once every 90 seconds, 2 minutes. If you're eating dinner, of course, you swallow much more often. If you're sitting in a lecture hearing about swallowing, you're probably going to swallow much more frequently than every 90 seconds. I can tell it's coming already. So this is me. So this is the inside of me. This is the outside of me. And so what I'm doing is I've just taken a bite of biscuit. So you can see on your right side of the screen is the spinal cord, that sort of bumpy bit down the back side. And then you can see the front in the mouth is on your left side of the screen, chewing up the biscuit. Now, once I've chewed that biscuit and I'm ready to send it back, I push the food into my throat, and in a very, very efficient and well-timed manner, it pushes the food through the throat, into the esophagus, down it goes to the stomach. What's quite remarkable about this process, one, it happens many, many, many times a day without you even recognizing so much what you're doing. But it also manages to get the food down the back of your throat through the esophagus, and it manages to avoid this tube. And this tube at the front goes to your airway, goes to your lungs. And it is, most of the time, about probably 6 or 8 times bigger than the tube to the esophagus. Those 2 tubes are separated by a little piece of skin about the size of that between your thumb and forefinger. So it's a remarkable process that we can do this over and over and over again, and very rarely does it go astray. That we're able to direct the food where we need the food to go, keep it away from where we don't want it to go, and enjoy all sorts of tasty things along the way. So, but for many people, the process doesn't go as smoothly, and this condition is called dysphagia, is the medical term for it. Now, you may not be an expert at interpreting x-rays, but I'm pretty sure that if you look at this one, you can see a big difference between this x-ray and my swallowing on the x-ray. The food moves very, very slowly through the throat. A lot of it just doesn't go anywhere, it gets stuck. And then quite a lot of it, you can see right there, is heading down toward the lungs. So that's the condition, and a quite severe condition, that we would term dysphagia. As a result, a patient like this would be unsafe to eat and drink because they would very likely get food in their lungs and get a chest infection. And so those patients would have to require feeding through another route. Now, I want to ask a question, a little survey here very quickly. How many of you know someone who has had a stroke? Yeah, that's pretty much everybody. Now, indeed, this might be a little bit of a biased audience because you've come to this talk. How many of you have known someone with Parkinson's disease? Yeah, quite a few of you again. Now, how many of you know someone who has been dysphagic? Very good. It is a bit of a biased population. Generally, if I do a lot of U3A talks around town, and it's yes to stroke, yes to Parkinson's disease, and no to dysphagia. I think the issue with dysphagia, it is unseen, but it's not uncommon at all. Dysphagia isn't a disease or an illness. It's a consequence of a disease or illness, and because of that, it can affect It can arise due to many, many medical conditions. So in New Zealand alone, we have approximately 7,000 new cases of dysphagia diagnosed every year, and that's in stroke and Parkinson's disease alone. That does not include children and infants with birth injuries, cerebral palsy, Down syndrome. It doesn't include adolescents who fall off their skateboard and whack their head on the curb, who have a brain injury. It also doesn't include many, many conditions in the, unfortunately, adult and aging population that wind up producing dysphagia: head and neck cancers, brain tumors, stroke, Parkinson's, motor neuron disease. The list goes on and on and on. So that figure of 7,000 new patients a year is probably only a small portion of how frequently dysphagia presents itself. The consequences? Well, chest infection certainly, as the x-ray you saw before. When food goes into the lungs, if the lungs can't get it out again, it results in an infection. Malnutrition and dehydration are very common. You just can't get enough food in. Prolonged hospitalization, and in the worst case, without treatment, unfortunately, death. We know that from some studies, and this relates to stroke only, 25% of stroke patients who are newly diagnosed with dysphagia are reported to die within 1 month, 50% within a year without appropriate treatment. And I want to emphasize that part, because you can do treatment for this condition. It's also very expensive. The mean cost of dysphagia in acute conditions is the equivalent of about 2,100, 21.5 New Zealand dollars per patient. It's about a 40% increase in the hospital cost. You have 2 patients in the hospital exactly the same, except one is dysphagia. That's 40% more in cost to the healthcare system. That equates, I worked with some folks from our economics department, that relates to about $3.5 billion per year to the New Zealand health system that is attributable to swallowing impairment alone. Now, where does that come from? Well, about a quarter of our stroke patients who require a feeding tube and are discharged, they're back in the hospital within a month due to secondary complications. So there are multiple admissions. For patients that are fed with a feeding tube, if you're not able to eat safely, then the way we get nutrition in people is to place a tube directly into the stomach. For patients that are on a feeding tube, it costs 53,000 New Zealand dollars per patient for 1 year to support a feeding tube. So we have a fantastic fellow, boy, he's terrific, Eric, who works for us at the Rose Center. Eric used to be a patient about 10 years ago. And as he says, yeah, I finished my treatment and I just wouldn't go away, so they decided to pay me and hire me. So Eric is our peer support person at the Rose Center. He has been off of his feeding tube now for about 10 years. If we hadn't gotten him off the feeding tube, that would have been about $500,000 for one single person. So it's an expensive problem to have for our health system, and of course for the patient that has that condition. And I guess at a more personal level, and I think for some of you this might be very personal, but for others, imagine if you couldn't eat, if you couldn't take any food in, and what would that mean to your life? What effect would that have on all aspects of your life? You know, we think about food and water as nutrition and hydration, and they are that. They are important for giving us nutrients and for hydrating us. But I think most of us would recognize that food and fluid does so much more than that, and that there is a very strong social component of food and liquid. Food is how we interact. I can remember when I was a very young clinician at one point, I went to see a family in their home. in the community. And I got there at about dinner time. They had a 3-year-old child that was dysphagic. So I get there about dinner time, and I walk in. The family was then sitting down at the dinner table. And it was mom and dad and 3 other kids, I think. And I asked, well, where's the other one? And they said, oh, she's in the back bedroom with the door closed because we didn't want to be eating in front of her. And although on the one hand I can understand that, on the other hand, where do most children learn to communicate? Sitting around the dinner table. That's where a lot of us learn our social engagement skills. It's also how we celebrate. Last time you had a birthday, what'd you do? You had birthday cake. You went out to eat. You had some champagne. You did all sorts of things to celebrate that birthday. And it's also how we grieve. When someone dies, a stream of casseroles make it to the back door. That's how we nurture people. So food is much, much more than nutrition and hydration. This quote really gets me. This was sent to me by Karen, who's the wife of a stroke patient. When talking about her partner, he said the other day that his was a world of almost. He could almost walk, almost talk, almost see, and almost swallow. And I guess when we look at all of the consequences of dysphagia, at least in my mind, there's a very strong mandate that if the healthcare system is going to save lives, the healthcare system also has to make those lives worth living. That we can't have people, that we go to great efforts to ensure survival, but then that survival is quite compromised, which is why I do the work that I do. I really like cheesecake, really like cheesecake. So several years ago, with my colleagues here at the university, we were given a very generous donation from a local Canterburyan to open the Rose Center for Stroke Recovery and Research. And the main focus of that center is to address swallowing and swallowing disorders, largely from stroke, but I have to say that we see pretty much anything that comes in the door. So the Rose Center is quite a unique facility from other centers in that we have very equal parts of patient clinical care. So we have patients that come to the center for treatment on a regular basis. That patient clinical care then informs our research and helps us decide what are the questions we need to be asking. And then that research helps to inform the development of bioengineering applications. So we have sort of equal parts of patient care, clinical research, and bioengineering developments at the Rose Center. So we've been open since 2016. We're located at St. George's Hospital in the Leinster Chamber building. I think very simply, our job is to fix swallowing when it's broken. That's what our focus is on. So you might ask the question, can you actually fix swallowing? That big question. It's a very good question. Swallowing is a reflex, or at least that's what all of our early research has told us. We all tend to think of swallowing as being something that we don't think about because it's reflexive. It just happens. And there was always a presumption that you can't rehabilitate a reflex because it's a reflex. How can you change that? But you should be able to strengthen the muscles that support that reflex. So historically, when we had a patient with swallowing impairment, we decided, well, if it's a reflex and all we can do is strengthen muscles, then we'll make them stronger. They must all be weak. This is sort of like the quote Maslow says that if all you have is a hammer, everything looks like a nail. And I think that's a very good quote in large part with swallowing, that if it's a reflex and we can't fix it, well then it must be weak. And we won't change the reflex, but we'll make the muscle stronger. But I think that one of the big questions we ask in our research program is, are all muscles weak? Are all patients weak? Is that true, or is it not true? Is that just an assumption? Also, is swallowing really a reflex, or is it something very different than that? And so, to answer those questions, I'm going to do a little experiment with you. This is class participation, even though you're not a class. You can tell I've been at uni too long. So, on the count of 3, I'd like you all to raise your right hand. 1, 2, 3. Well done. All right, you all passed. So, if you're cooperative and if you have a right hand, then you could all do that with no difficulty whatsoever, right? Now, if I told you for the next 3 minutes, do not raise your hand. Now, I'm not going to sit here and stare at you for 3 minutes, but it's very likely that, again, if you're cooperative, nobody's going to raise their hand in the next 3 minutes. And that's because hand raising is a purely voluntary behavior. Your brain says, oh, I think I might raise my hand. And it sends the signal from the left side of your brain down your right arm and you raise your hand. Or it doesn't. It's completely voluntary. So let's do something a little different. On the count of 3, I want you all to have a single heartbeat, please. Right? 1, 2, 3. Did you do it right then? Yeah, who knows? And, you know, the inverse of that, for the next 3 minutes, no heart beating. Well, I'm really hoping that nobody can do that. You don't have control over your heartbeat in that way. The heart will do what the heart wants to do. It just keeps beating. It is a reflex. It sticks to a schedule, doesn't let you down, and it keeps you alive. So on one end of the spectrum, we have hand raising. On the other end of the behavior spectrum, we have heart beating. Where's swallowing? Where does swallowing sit? So on the count of 3, here we go again. On the count of 3, I want you to all swallow. 1, 2, 3. Now I can't really see you all because most of you have masks on. But I'm guessing that that's not too terribly tricky. Right? That on the count of 3 you can swallow. You can voluntarily initiate that behavior. Likewise, or on the other hand, if I tell you for the next 3 minutes, do not swallow. Well, now some of you are going to be really stubborn and say, I can do that. Yes, I can do that. I can do that. Others of you, because you're thinking about swallowing, you might make it about 10 seconds and then you're going to swallow. But for the most part, within about 2.5 minutes, all of you will have swallowed. You won't be able to inhibit that behavior for too long because that behavior protects your lungs. So it's really important in that regard. So now there's the second unique characteristic about swallowing. Swallowing's this funny thing again. It's not reflexive. It's not volitional. It sort of slides around in the middle. When you're sound asleep at night, you swallow to take care of the secretions in your mouth. You don't wake up to do it. Your brain's turned off. It happens. But when you sit down to eat your dinner tonight, whatever that is, then you have a lot of voluntary behavior in eating. Now, the second unique characteristic about swallowing makes it particularly responsive to rehab. Now, think about driving from Christchurch to Akaroa, right? You've got one road, essentially, that goes from Christchurch to Akaroa. So if there's a slip and the road's washed out or covered up or whatever, you're not going to be going to Akaroa unless you're going in a boat, right? So that's a very similar scenario to most of the nervous system. The right side of the brain controls the left side of the body. It's a pretty direct pathway from the right side of the brain down. So if you damage that pathway, very hard to get the signal through, and therefore it makes recovery very difficult. Now, imagine that after the talk tonight, let's pretend that you all live up in a big fancy house on the Kashmir Hills, right? So let's say that a big old truck overturns on Rickerton Road, and you can't get down Rickerton Road. You're still going to get home, aren't you? Because there's lots of different ways to get to Kashmir other than going down Rickerton Road. And that's how the brain organizes swallowing. For swallowing and other tasks that are very important for survival, there's an amazing amount of redundancy in the system. So the right side of the brain controls the left side of the throat and the right side of the throat. About half the fibers go one side, the others go the other side. And the left side of the brain controls both sides of the throat, except for one or two little muscles. So it's this amazing system that if you damage one side of the brain or one of those pathways, well, that's okay. We just have to figure out how to get the other side of the brain to take over. So it's an amazing system. It's a really very clever system that for breathing and swallowing, you have this bilateral innervation that is protective. It keeps you from getting into prolonged trouble. So that's what makes rehab potentially, of all of the other types of neurologic impairments, in some respects, swallowing may be the one that is most amenable to rehabilitation because of that neural control mechanism. So this is great. In our patients with swallowing impairment, we have a nervous system that is highly adaptable to support recovery. Terrific. So it should be really easy, right? Yeah, it's not. You look at a patient and say, oh, hello, Mr. Smith. Good to see you. I'd like you to swallow. Squeeze the muscles at the top before the muscles at the bottom by about 300 milliseconds. You do that now. It's like, how do you do that? The big stumbling block that we see with swallowing is that we don't see swallowing, right? If you didn't have a mask on and if I looked at your throat really closely, I could see movement, but I can't see swallowing. And certainly from a patient point of view, patients don't know what goes on in the throat, right? So it's very hard to change what you cannot see. And that's our big stumbling block in swallowing. So my task as a clinical researcher is finding a way essentially to see swallowing that will allow patients access to rehabilitation. That's what we've been working on for quite some time. Now, I've taken a few hints from our colleagues in physiotherapy. Now, this video coming up is as old as the hills, and the quality of it is a little bit grainy, but it works a treat, so please bear with it. So this is a woman with Parkinson's disease, and she's walking with her physiotherapist. Physiotherapists always wear black trousers. That's the physiotherapist. So, and you can see if you look at her feet, she's a very typical advanced Parkinson's disease that's not responding to drugs. She has a lot of trouble changing directions. Now the physio, all she's done is put little markers on the carpet. That's it. Nothing's changed, no medication, no time has lapsed. They just put little markers on the road, and now that behavior in her feet has gotten much more organized. So she's able to walk from one end of the room to the other one. Physio can take the white markers away, and she can keep that in her brain for a while and continue to walk quite well. So that's a really good example of if you get the right feedback, the right visualization, you can do a lot to change behavior. So when I watch those feet in that video, do you know what I see? I see a tongue. That's exactly what a tongue does in advanced Parkinson's disease. There's a lot of little bitty inefficient movements that have trouble transferring the food. And when it transfers, it's really inefficient. So, several years ago, we developed a treatment approach at the Rose Center that uses a little patch of electrodes that goes underneath the chin. You can see under the patient's chin. There's a little sticky patch that has wires coming out of it. That connects with what we call an EMG, electromyography device, that little box on the table. And that little box measures the electrical activity of muscles as they contract. Now, very similar to what the patient with Parkinson's did when she got visual feedback, what we ask patients to do, what the blue line on the screen is an EMG waveform. The patients learn to control swallowing by controlling the line on the screen. So they're instructed to hold the line very still, and then when they swallow, they need to put the hamburger at the end of the line in the mouth. If they hit the target, which she didn't then, but if they hit the target 3 times in a row, then the target gets smaller, so they have to be more precise. If they miss the target 3 times in a row, it gets a little bit bigger, so it makes it a little bit easier. And so what they're doing is, by doing that repeatedly, practicing swallowing and practicing control of the muscles in swallowing, then they're engaging the cortical networks, the networks in the top of the brain, to help control swallowing behavior that generally occurs in the bottom of the brain. So they're gaining cortical control over swallowing. So that was a really good first run. When we came out with we called it Biscuit, because at the time we had a young engineering student working with us, and we couldn't think of a good name for this. So I get up at stupid o'clock in the morning at about 3:30, and I'm working at my computer, and he pops up in my Skype window, and he had just come in from drinking most of the night, and he said, "I got it. It's Biscuit, biofeedback and strength and skill training." And so the name has stuck. So that's our Biscuit software to work mostly on skill training for swallowing. In our first study that we did with that particular software, that was in patients with Parkinson's disease. After 2 weeks of treatment, patients responded very, very well, and they were able to maintain the gains that they had made through a very short treatment course that exceeded the duration of the treatment course beyond. So they did very, very well with that treatment. Now, that was a really good start to try to explore how well can we control swallowing. But it really doesn't prove that we can change individual components of the reflex, only that they can swallow at one point in time. So we wanted to look a little bit further. Now, in 2014, we challenged current thinking, and we proved for the very first time that actually you can control individual components of the swallowing if you have the right kind of visual feedback. So, let me explain this, because that's a very confusing looking slide. I have never milked a cow, I will admit that. But to my very naive understanding, if you want to milk a cow, you squeeze from the top to the bottom. Is that right? I assumed that that would be the case. And if you don't squeeze from the top to the bottom, you're probably going to leave a little bit disappointed, and you're going to have a very angry cow, right? So if you squeeze the wrong direction or squeeze all at once. That's exactly how swallowing works. When all of us swallow, or anybody that's not dysphagic swallows, you squeeze from the top of your throat to the bottom of your throat. When you watched my x-ray, the food came in, I squeezed from the top to the bottom to push it into my esophagus. That makes sense, right? However, we found an interesting little group of patients that when they swallow, they don't squeeze things in the right order. So instead of squeezing from the top to the bottom, there's this curious group of patients that when they swallow, everything contracts at once. Or they squeeze from the bottom to the top. It's a curious bunch, and they're almost every patient we have seen who has had a very specific lesion at the back of the brain. There's something called the cerebellum that's responsible for motor control. Every single patient with that lesion, when they swallow, they either swallow backwards or everything at the same time. It's a very curious problem. And of course, when you swallow backwards or everything at the same time, then you could imagine what would happen if you have a tube of toothpaste and you squeeze from the top to the bottom, it goes down the bottom into the esophagus. If you cut the top off and you squeeze it, some of the toothpaste stays in the throat, in the tube. Some of it goes up in the nose. Some of it goes in the esophagus, and some of it goes in the airway because you haven't told it where to go. You don't have good direction on that. So now that's a really curious problem. And how do we fix that? So we used a different kind of visual feedback. Now, manometry is a tool that measures pressure, right? Very simply, it just measures pressure. So we have a little bitty tube. It's about like a piece of spaghetti. It's nice and floppy, like a piece of spaghetti. But embedded in that tube are 3 little sensors. We're mostly concerned with the top 2. And so if you see in the middle of the x-ray, there's a little tube that goes down the back of the throat, and those arrows are pointing to a couple of sensors. What we expect to see in healthy swallowing, if you bear with me, this is a little complex. On the left-hand side, we expect to see that there's a pressure wave at the top of the throat, and as that pressure wave starts turning off, there's a pressure wave in the bottom of the throat that represents that squeeze from the top to the bottom. Now, in these patients that missequence, for lack of a better term, they look like the image on the right, where everything just closes at once. So we decided to use this technology as a biofeedback device, as a system for those patients to see that behavior. The example I used before that I directed over here to somebody, Mr. Smith, whoever that is, oh yes, I want you to swallow and I want you to squeeze from the top to the bottom. Well, how do you do that? The way that we do that is we provide a very intensive treatment program. We place a little catheter that goes in the nose, down into the throat, and then we ask the patient, I want you to watch those waveforms. Make the blue line come first. And they look at us and they say, you want me to do what? And I'm like, yep, make the blue line come first. Well, how do I do that? I'm like, don't know. Just do it. Watch the lines, make the blue line go first. And sure enough, they're able to do that. By the end of the first week, they're able to shift the lines. By the end of the second week, they can do it consistently to swallow much more normally. So that approach is looking very good. We reported on a group of 16 patients who had this problem. 11 out of 16 were able to return to a normal diet and go on and do very, very well. Of the 5 that didn't return to a normal diet, 4 of them could only do 2 weeks of treatment. And 2 weeks just isn't enough. It's pretty labor intensive to change the way you swallow. But for the ones that could continue treatment a little bit longer, they did very, very well. Now, there's another tool that we can use to address this fancy thing. This is similar to what you've just seen, but the catheter, instead of having 3 sensors, it's got 36. It's sort of what we were doing before on steroids. And so it comes out with this multicolored picture. And what you see on this image is where it's blue, it's very low pressure. Where it's red, it's very high pressure, and everywhere in between. And time goes along the horizontal axis. So time goes across the screen. And so using this image, we ask the patients to learn to control swallowing by controlling the colors on the screen. Now this is a fellow named Tony who's given permission for you to see his video, I might add, as had Eric before. And so Tony's come in for treatment, he's got the tube in, and he's trying to learn to control the way he swallows by watching the colors on the screen and by changing the shape of those color patterns on the screen. Now I think that Tony explained it the best. This is a quote that Tony gave us. The key point on this is the second part. It's amazed me how my brain can take what I see on a screen and convert it into actions in my throat. It's that our big stumbling block in rehabilitation of swallowing is finding some way to see swallowing. So if we can use technologies or create new technologies that allow patients to see some aspect of swallowing, then they're able to manipulate swallowing, because most people don't know what goes on in the throat. So you manipulate it by manipulating something external. So, oh goodness, look what time it is. So, can we rehab a reflex? Well, yes, indeed we can. I think the research in our laboratory has shown that people are able to modify even little bitty components of swallowing. The presumption is that by first changing behavior, if you do that over and over again, you encode that into the brain. So that's the new motor pattern, and that certainly is what we've seen. I just wanted to toss in this other study, not from our lab, but from another lab that's really interesting. They did an MRI study of people swallowing, and essentially people imagining that they were swallowing. So they're not actually swallowing, they're just thinking about it. Think about swallowing. And they've identified that the parts of the brain that are activated in swallowing are also activated just when they think about swallowing. So if we can get people to really think about swallowing in a very concentrated way, they should be able to modify that behavior. So what's next for us? We work very closely at the Rose Center. We hired our own biomedical engineer that works at the center with us, but we also work with colleagues at engineering here at the university. And so we're continuing to develop technologies. We've got 3 other technologies that are coming down the pipe at various points of development. The Biscuit Software, after we developed that, we got the request from clinicians to use that. So we went ahead and we got medical device certification, put it on the UC website, and kind of ignored it because we had other things to do other than worry about selling software. It actually did much better than we thought it would, as a matter of fact. But we got some very good feedback from clinicians. One, they had great enthusiasm for our skill training approach. That was the good news. But clinicians are under-resourced, and they can't provide the intensity of treatment that's required. And I think that's a big stumbling block in most healthcare systems, not just New Zealand, but everywhere, is that clinicians can't see patients every day. And when acute stroke patients leave the hospital, they're really limited in how much rehab they can get. We also had a request that if you're gonna revise it, can you give us a telehealth option? And certainly 2 things have influenced that. Our healthcare system is increasingly decentralizing, wanting to do healthcare in the home and getting people out of the hospital. That's a great thing. But we've also had little COVID has come along where people can't go into hospital. So what we're working on now is changing our Biscuit software to be Bisc app. And so we've got a tablet with an app installed and a little bitty wireless EMG device. It's just that little block. The patient sees the clinician in her office who teaches him how to use the device. He takes it home, places the electrode under the chin, and then turns the app on. So when he works on making this line go higher, he's working on muscle strengthening, if that's what he wants to do. But he can also work on placing the burger into the mouth to work on precision in timing and amplitude of swallowing. Now, the main idea then is that once he does his treatment at home, maybe 3 times a day for 10 minutes, those data transfer back to the clinician via the cloud, whatever the cloud is. I am so not into what is a cloud. I don't get that, but it's magic. And so the data go back to the clinician. Then the clinician can adjust the treatment plan as needed. When the patient finishes treatment, he turns the device back in, and that device can go out to a new patient. So that's what we're working on now. We'll be starting in January a very big longitudinal randomized controlled trial. The trial is starting in New Zealand, but then it will pick up with recruitment in Australia, Germany, and Switzerland. So we're looking at an international trial. And going along with that, our Biscuit Software, I'm an academic. I don't have time to mess with selling stuff. So we stuck it on the website and ignored it. That's not going to work anymore. And we have decided that we need to come up with a better solution. So in April of 2021, last April, we established Swallowing Technologies Limited, which is a UC startup, and it will be the conduit between technologies at the research lab and the community of patients and clinicians that can make use of that. So we are commercializing some of our technology. The portion of my shares then feeds back into the Rose Center so that we can support further research at the Rose Center. We're in the midst of our first seed investment round, but we've already come away with 3 awards or prizes for the technology. So I guess I want to close with this comment that, in this age of technology, the very best, most clever gadget is the human brain, and I absolutely believe that. It is an amazing, amazing structure. However, nothing says we can't help it out a little bit. And I think certainly for swallowing, which is such an obscure activity, the use of technology is going to be very important to move forward. So I do as I always did. I talk too much because I kind of like to talk a little too much. But I would love to take any questions or comments or curiosities if anybody has any. Hi. Yeah, I think his question was, can you use the technology for other activities? So potentially limbs you could use it for. You could potentially hands in particular because they're little. Thinking in terms of focus or attention, probably not, because it measures muscle activity. Those sensors measure muscle activity. But any other muscle, if you need to learn to control that muscle, potentially you could do that. Mm-hmm. Yes, ma'am.
I'm thinking about Biscuit and those other apps. How does someone who's nil per mouth do swallow after swallow after swallow to do that? Mm-hmm.
Absolutely, and certainly we've had a lot of years of trying to sort of puzzle through that. If you, generally most patients are able to swallow about once every 30 to 45 seconds without fluid. So if you just sit in your chair, after 30 seconds, you'll swallow the spit in your mouth, the secretions in your mouth. And then in another 30 seconds, you've produced enough secretions that you'll swallow those secretions. Now, some of our patients are on drugs that dry up secretions. That's not at all uncommon. A lot of the drugs that people take will reduce secretions. And so those patients might need a little bit longer. So generally on the technology, the screen sweep you can change. It's usually by default set at 30 seconds. And many patients have no trouble with that. Some do. So then we increase it to 45 seconds or 60 seconds. It just means you have to go slower and not do as many repetitions, but they build up secretions. We also sometimes will use a little spritzer bottle of water in order to moisten the mouth so that they can keep swallowing. Oh, great question. Her question was, how do you assist or help people if they are blind? Really interesting. You know, I've been doing workshops on EMG biofeedback since probably 1994-ish, like a long time ago. And I visited a hospital at one point, and they had this EMG device. It was amazing. It didn't give you lines on a screen. It gave you sound. And some of the devices have a beeping tone. So when the line is at the bottom of the screen, it goes beep, 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 beep. As a clinician, it's really annoying. But it's not about me. If you have a patient who doesn't see very well, it's a really good feedback system. People who are visually impaired have very good sense or very good auditory senses. And so it's just a matter of setting up the software. And that's a really good reminder we should make BizCap have noise so it can drive clinicians crazy but be good for patients. Yeah, great question. Mm-hmm. Yes, ma'am.
So we live in a site, you were saying you have 7,000 new cases a year. Then you mentioned a whole category of people that obviously have some sort of swallowing issues. Now I have a young client with Down syndrome
Yes.
who can override the gag reflex and swallow enormous growths and things like that. Not really successfully, but very bad for the digestive system, etc., etc. Is that primarily from, a structural thing, from birth, or is that
Yeah.
muscle tone, or?
Gag is a funny thing, you know. So if I pulled out a little wooden spatula, not one, but many, and went around the room and tested the gag of everybody in this room, I'm not going to, don't worry. But if I did that, about 35% of you wouldn't gag. That there's a fair number of people who don't have a gag response. And so when we test gag, essentially if the person gags, it tells us something that nerve is doing its job. If they don't gag, it doesn't tell us anything. Because some people just don't gag. Mm-hmm. Oh, yes, ma'am.
Would this biofeedback work when you've got muscle damage only, autoimmune disease?
You know, I think that there are so many conditions that produce dysphagia, and I would not right here say, yes, it would work. But I also would not right here say, no, it would not work. I think that you have to try, in my view. Now, certainly for muscle disease, we would probably work on muscle strengthening as opposed to skill-based training. But I think that there are so many different conditions. You know, another group, patients with motor neuron disease. We've always thought motor neuron disease, you can't do anything. You can't help people with motor neuron disease. But actually, current research is challenging that. We can't make it go away. Of course, we can't make it go away. But we may be able to prolong function through rehabilitation.
At what part of the esophagus does peristalsis take over?
Sure.
or?
Great. Good question. So I'm supposed to be repeating questions. At what point in the esophagus does peristalsis take over, or that sort of automatic just passing down a tube? There's a funny little muscle right here at the top of the esophagus called the upper esophageal sphincter. Funny that. So it just sits right at the top of the esophagus, and it's what separates the throat from the esophagus. As soon as the food gets through there, there's no option but it to go down the tube. Now, sometimes it gets caught up in the area of the heart, so people will have slow motility, and the food won't go down very quickly. But it's a closed tube from here to here, so it can't get in the airway, it can't go up the nose, it just goes down. Any other questions?
I have a question.
Oh, I'm sorry.
I just mentioned how important intensity is for dysphagia rehabilitation. If a clinician does have access to a software such as Biscuit, but can only do that once a week with the person, would there likely be benefit to the rehabilitation?
I think this is the frustrating part for me, because I work in a center where we can do whatever we want to do. So we just see patients for an hour in the morning and an hour in the afternoon. And I know in healthcare systems it doesn't work like that, because I worked in one for about 20 years. I think that recovery would be very, very slow, if at all. That I think all of the research tells us that if you want to reorganize a brain, you can't do it once a week and expect it to happen. Well, heck, if I went to the gym once a week, I probably wouldn't become a whole lot more fit. I'd just become a whole lot more miserable, as a matter of fact. So I think that that's really what's pushed us to develop this gap, because clinicians can't provide that treatment with the intensity that it's needed. But if they can set it up where the patient 3 times a day gets a little reminder, ding dong, go do treatment, and they go do 10 minutes of treatment, turn it off, put it away. 2 hours later, ding dong, go do treatment. 30 minutes later, they haven't done treatment. Ding dong, why didn't you do your treatment? So, and then if the clinician could monitor it remotely, then I think that's a way that patients can get the intensity of treatment. And certainly we hear one of the concerns about this is, will many of our elderly patients be able to do it? And, if you look at the literature on that, we never want to underestimate an elderly patient. That I think they can do a lot more than we give them credit for, and they can learn to do that. And they've got grandkids. And you got grandkids, you can do any technology. So I think that that's the big thing. You just go find the grandkids and bring the grandkids over, and then there you go. Yes?
I have 2 questions. Firstly, does this have to happen fairly soon post-stroke or early progression to work, or can this work quite a long time afterwards?
Okay, great question. So her question was, I'm remembering, see, I can learn to repeat questions. Does this have to happen right after stroke, or can it be more remotely from the stroke in terms of treatment effect? And I gotta say, well, in our clinical trial coming up, we are starting the clinical trial that as soon as they hit the hospital ward and they're alert enough, they start treatment. However, having said all of that, because we're hoping that will boost neural recovery by practice. But when I look at patients who have made the most astonishing recovery, they've been patients who were 3.5 years post. And I've had patients who have gone they had nothing, hadn't eaten in 2.5, 3 years. And after some intensive treatment, they were back on a normal diet. So I think time post-onset does not matter as long as you do the right treatment. The time post-onset is nothing to me.
So my second question was, if you can do this rehabilitation with color, would it work for cough? Would it work for cough
Yes, the difference with cough, her question was if you could do this treatment at home, would it work for cough as well? And I think that the funny thing about cough is, cough is a motor behavior. It can be voluntary, it can be reflexive. But when we need a cough, isn't during voluntary behavior, it's when food goes the wrong way, you need a reflex. And that's a sensory response. So if your sensory system isn't working very well, you don't cough. So training the motor task of coughing isn't going to necessarily change the sensory. Yeah, but good question. So I've gotten the last question with that one. So come and talk to me, Karina, and I'll answer your questions separately. But I thank you all for joining me this evening and letting me talk about the work that I do. I've been looking at this thing called swallowing that takes 800 milliseconds for about 42 years, which one might consider that I'm a very slow learner if I haven't figured it out by now. But it really is quite a fascinating area, and if anybody at any point would like to get back in touch with me at another point, I'd be very happy to speak with you. So thank you all, and safe journey home. Thank you.